Google has just done something no other tech company has done before. Signed a groundbreaking deal to power its AI operations using nuclear energy. Not just any nuclear energy, but energy from small modular reactions, SMRs. This isn't just another corporate energy agreement. This deal could redefine how tech giants power their massive data centers in the future. So, why nuclear? What are SMRs, and what makes this partnership so special? Let's dive right into what we know so far. Why Google needs nuclear power for AI. The world of artificial intelligence is exploding, and along with that comes an enormous demand for energy. Google's AI systems like Bard, cloud platforms, and even future models are data-hungry beasts that require 24/7 electricity. Running large-scale data centers consumes massive amounts of power, as much as some small countries. With AI advancing so quickly, Google is faced with the challenge of ensuring reliable, uninterrupted energy to support this growth. While solar and wind energy have been a part of Google's green strategy, these sources aren't always available when needed. The sun doesn't always shine, and the wind doesn't always blow, making it hard to maintain a consistent supply. This is where nuclear energy steps in. It provides a stable, low-carbon power source that runs around the clock, exactly what Google needs to avoid downtime in critical AI operations. Nuclear ensures that even when demand spikes, the power keeps flowing, and data centers stay online. But Google's decision isn't just about reliability, it's about meeting sustainable goals. The company has long aimed to reduce its carbon footprint, and nuclear power, which emits virtually no carbon during operation, aligns perfectly with that mission. However, Google's shift to nuclear also raises some eyebrows, which we'll get to in a moment. What is the Kairos Power deal? Google's partnership with Kairos Power marks a first-of-its-kind deal in the tech world. The agreement involves the purchase of 6 or 7 small modular reactors, SMRs, with the first reactor expected to go live by 2030 and the rest operational by 2035. Google aims to acquire 500 megawatts of energy from these reactors, enough to power a medium-sized city. So, what makes this deal unique? Kairos Power's SMRs are not your traditional nuclear reactors. Unlike massive nuclear plants, which can take decades to build and often suffer from delays and budget overruns, SMRs are designed to be smaller, faster to deploy, and more cost-effective. They're built modularly in factories and assembled on-site, cutting down on construction time and reducing risks associated with larger nuclear projects. Kairos Power, founded in 2016, is still in the process of building its first demonstration reactor in Tennessee, expected to be completed by 2027. The reactors Google has ordered are based on a molten salt design, which promises greater safety by using liquid salt as both a coolant and a fuel carrier. This innovative design helps prevent overheating, one of the major risks associated with traditional nuclear reactors. While Kairos Power's SMRs are still subject to regulatory approval, the fact that Google is moving forward with such a deal shows confidence in the technology. The partnership also reflects a growing trend among tech giants looking for innovative energy solutions to meet the needs of their expanding operations. Other tech giants moving toward nuclear energy. Google's foray into nuclear power isn't happening in isolation. Other tech giants are also exploring nuclear energy solutions to meet their growing energy needs. Microsoft recently partnered with operators at 3 Mile Island, making the site's first reactivation in 5 years to support the company's expanding cloud operations. This revival is notable, given the 1979 meltdown that made 3 Mile Island infamous. Microsoft's choice highlights how critical stable energy has become for companies managing AI and cloud workloads. Similarly, Amazon took a big step earlier this year, acquiring a nuclear-powered data center from Talon Energy in Pennsylvania. This move signals the company's interest in nuclear power to keep pace with AI and cloud growth. What's clear from these decisions is that tech firms are recognizing the limitations of traditional renewables and the need for uninterrupted power sources to avoid downtime. AI doesn't sleep, and neither can the servers powering these technologies. The shift toward nuclear energy reflects an experimental stage, with SMRs and revived plants representing a relatively untested path in tech operations. While companies like Google, Microsoft, and Amazon seem confident in the potential of nuclear power, it remains to be seen whether these efforts will scale effectively. Nuclear investments are costly, and the risks of regulatory delays or public resistance could complicate the rollout. However, if these projects succeed, they could set a new precedent for energy use across the tech sector. The outcome of these initiatives will have implications far beyond the companies involved. If nuclear-backed AI operations prove sustainable and reliable, more firms may follow suit. But if costs or other challenges become prohibitive, the focus may shift back to renewables or innovative solutions like advanced battery storage or hydrogen energy. Regardless, the tech sector's experimentation with nuclear power marks a pivotal moment, hinting at the energy strategies that could shape the future of AI infrastructure. The debate around nuclear and SMRs. While Google's deal with Krios Power seems like a bold move, it's not without controversy. Let's take a closer look at both sides of the debate to understand the pros and cons. On the pro-nuclear side, experts argue that nuclear energy is clean, efficient, and reliable, everything a modern AI-driven company needs. Unlike fossil fuels, nuclear plants produce no carbon emissions during operation, helping companies like Google meet their sustainability goals. Proponents also highlight the scalability and flexibility of SMRs. Their smaller size means they can be built in locations that wouldn't be sustainable for traditional reactors, offering more opportunities to integrate nuclear power into urban infrastructure. However, the critics have their concerns. One of the biggest criticisms of SMRs is cost. Even though they're designed to be cheaper and faster to build, scaling them up to meet global energy demands could still be more expensive than focusing on renewables like wind and solar. Critics also warn that nuclear waste disposal remains an unsolved issue, with SMRs adding to the growing challenge of managing radioactive waste. Moreover, safety concerns linger despite technological advancements. Although SMRs are designed with safer cooling systems, public skepticism about nuclear energy remains high, largely due to high-profile accidents like Chernobyl and Fukushima. The involvement of companies like Google might help shift public perception, but it'll take time for people to feel comfortable with the idea of nuclear-powered AI systems. Lastly, environmental advocates argue that renewable energy still offers a more sustainable long-term solution. They suggest that the focus on nuclear might distract from efforts to scale up wind and solar capacity. For many, the real question is, why invest in nuclear when renewable technologies are becoming more efficient and cost-effective by the day? What this means for the future of AI and energy. Google's shift toward nuclear energy isn't just about keeping its data centers running smoothly. It highlights a broader trend where AI technologies and clean energy solutions intersect. AI development demands constant power, and if this model works, it could revolutionize how tech companies manage energy resources. For countries aiming to reduce dependence on fossil fuels, SMRs offer a promising low-carbon alternative. However, this transition also raises important questions. Will nuclear energy become the backbone for tech infrastructures, or will investments in renewables like solar and wind remain the priority? Success with Google's reactors could trigger more companies to adopt similar strategies. On the flip side, challenges like regulatory hurdles, public skepticism, and high setup costs might limit its adoption. This new energy landscape reflects a shift in corporate responsibility. It's not just about staying profitable, but ensuring sustainability and addressing the climate crisis while balancing business needs. The tech industry's experiment with nuclear energy could be a game changer if it unlocks reliable, clean energy to support AI growth. Challenges Google could face with the SMR strategy. While Google's move into nuclear-powered AI operations sounds groundbreaking, it's not without risks. Building and scaling nuclear reactors, even modular ones, is costly and comes with regulatory complexities. Krios Power's reactors still require approval from the U.S. Nuclear Regulatory Commission, and any delays could disrupt Google's ambitious timelines. The molten salt design promises safer operation, but nuclear energy will always carry public perception risks. One accident could shift opinions overnight. There's also the issue of nuclear waste, which remains a long-term environmental challenge. Even though these reactors are designed to be safer and more efficient, they still produce radioactive byproducts that need careful management. Additionally, scalability may be a problem. Nuclear projects often run over budget and behind schedule, even when modular designs are involved. Google's reliance on nuclear energy also raises questions about whether other companies will follow or prefer to stick with renewable energy sources like solar and wind. Google's venture into nuclear energy reflects the growing complexity of the tech-energy relationship. As AI models grow more powerful, so does the need for constant and sustainable energy. Nuclear power offers one path forward, but it's not without risks. Cost, scalability, and public perception remain significant hurdles. With the first reactor expected in 2030, the world will be watching to see how smoothly this rollout goes. This deal opens up new questions. Will other companies follow in Google's footsteps? Can nuclear-powered AI operations set a new industry standard, or will future efforts shift back toward renewable energy? It's an exciting and uncertain road ahead, and how Google navigates this transition will likely shape the future of tech infrastructure for years to come. If you've made it this far, let us know what you think in the comments section below. For more interesting topics, make sure you watch the recommended video that you see on the screen right now. Thanks for watching.